let's going to study a new subject. Well, it is the same subject, but we are going to just apply several subjects in one. In this case, we are going to combine oxidation states, half reactions, global reaction with stoichiometry and limiting reactant. Some questions doesn't necessarily tell you that you have to find the limiting reactant, but you will see that when you have like the two quantities of the reagents in a reaction, it means that it's forcing you to find which is the limiting reactant, because one of those two will consume first, and our task is basically to know which of those two it will be one it will be consumed first. Alrighty, so let's solve. My time advice is always try to solve which is easier first. So what is easier between working with limiting reactant and oxidation states? Oxidation states indeed. Yes, so let's work with the oxidation state for zinc. What would be the oxidation state for this element, which is pure? Remember, if it is pure, it means that always the oxidation state will be 0. What about this one? We have copper, sulfur, oxygen. Let's go first, always for those which is very easy to find the oxidation state, which is oxygen and hydrogen. So let's go for oxygen. It is always -2, except when we're working with hydrogen peroxide. Then we have sulfur. What would be then the oxidation state for sulfur? Well, if you don't remember what is the oxidation state with sulfur in this kind of situation, always work with sulfuric acid. What is the thing with sulfuric acid? You already know that hydrogen, it is +1, right? So if you have +1 and oxygen is -2 and you have 4 of them, that's -8. And you have +1 times 2, that's +2. 8 negative plus 2, it is 6 negative. Therefore, to have a 0 value with addition of all these oxidation states, mandatory sulfur must be +6. Now, what is the thing with this? The thing is, we preserve the structures. So if you find SO4 in any chemical reaction, always SO4 will have the same oxidation states, which means that sulfur must be as well +6. Okay? And in that way, we can just predict the value for the oxidation state for sulfur in certain cases. But remember, only works with SO4. With SO4, sulfur is always +6. Now with that we know sulfur is +6 and oxygen is -2. We have -8 minus 2 times 4 plus 6, that will be -2. Therefore, to be positive will be 0, copper must be +2. And that's it, how we know what is the oxidation state for copper. Let's go for the next one. It is exactly the same. So oxygen, it is -2. What we said, anytime that sulfur, it is on SO4, sulfur always will be +6. If we have this, always the oxidation state for the partner, if it is just repeated once in the molecule, it will be +2. Then we have copper, which is alone, therefore oxidation state, it's 0. Now, half reactions. Let me erase this because we don't need it anymore. Done. All right. Now, let's find the half reactions. So the half reactions are focused on those elements that they suffer a change on the oxidation state. So let's begin left to right. So we have zinc. Zinc is 0. What would be the oxidation state of zinc on the product side? Following what we did, zinc must be +2. Okay? But if we are passing from zinc to zinc 0 to zinc +2, it means then how many electrons? Okay, by the way, is it this a reduction or is it this an oxidation? Remember, the arrow's 0. If the value turns more positive, it means that it's losing electrons. If the value turns more negative, it is gaining electrons. In the same way, if you have a very positive value and goes more positive, it means it is oxidation. If you have a very positive value and it turns less positive, then it is a reduction. So we have here is positive to, it is 0 to positive, so it goes in this direction. Therefore, this is the direction for oxidation. Everything if it goes up, it is oxidation. So when we are going to write the oxidation for zinc, it will be zinc plus 2 plus the 2 electrons that zinc is losing. Why we write it in this way? Because we always have to write the equation in terms that if I change the arrow, the equation makes sense. So if you have the ion plus 2 electrons, you will have again your zinc 0, right? So in that order of ideas, if zinc 0 it is split into the ion, it will have also the electrons on the other side, because it's kind of like a product. It is not possible to be seen, but it is there. Okay, now let's look for the next one. The next one would be copper. So copper, it is plus 2. Copper is plus 2, and on the product side, it is copper 0. So what is telling us this? It is telling us that copper, it is suffering a reduction because it's passing from a positive value to a 0 value. So it is losing positive charges, it is gaining negative charges, therefore it is gaining electrons, it is a reduction. Now, how many electrons requires copper to turn to copper plus 2 to copper 0? Just 2 electrons, because this value over here, it is telling us the amount of electron that lost initially, and is exactly the same of electron that is required to turn the molecule or the element again into the most the value of 0. All right. Now we know that everything is all right when we are able to cancel the amount of electrons. If we are able to cross out the electrons on both sides, remember that 1 electron, 2 electrons are on the product side, meanwhile in this case the 2 electrons are in the reagent side. So when we cross out those values, we have the final reaction, what is called the global reaction. It will be copper plus 2 plus zinc 0. It is producing zinc plus 2 plus copper 0. With this, we have finally the global reaction. Okay? So we fulfill this step over here. Yay! Completed. Okay. Now we have to do the complicated part. Finding the limiting reactant. So as I told you before, the limiting reactant is basically find what is the reagent is going to consume first. Therefore, it will be the reagent that will produce the less amount of product possible. When we are looking at limiting reactant, what actually we are looking for, it is the ratio between the reagents and the products. All right? In this case, we have 2 products. We have zinc sulfate and copper. Which of those 2 would be the product that I should looking for in the relationships between the reagents and one of the products? Following the problem is highlighting the presence of copper. Therefore, I have to do my comparison between zinc and copper and between copper sulfate and copper. If you pay attention in the question, they are giving us the mass of zinc, which is one of the reagents, and the mass of copper sulfate, which is another of the elements there. Okay, as we finish with the half reactions, I'm going to erase. Remember, you can just rewind. I don't know how to say this. I'm too old for this. All right. Okay. So, first step, always, step number 1, Rule of rules. Turn everything they give you into moles. So I have 70 grams of zinc. What in the name of God? It is 70 grams in moles. So I have to look for the atomic weight for zinc. The atomic weight for zinc, following the periodic table, it is 65.4 grams of zinc. It is equal to 1 mole of zinc. Remember how it works, the rules. The unit that you have, you are going to set it on the bottom, the denominator. The unit that you are looking for, you are going to add it above in the numerator. So the one that is related grams per mole, it is the atomic weight for elements, and the molar mass for molecules. Remember, that's the only difference. The molar mass is nothing more than addition of several atomic weights, but they're equivalent. All right, so how much would be this? How much is 70 divided by 65.4? I don't know what should be that, so let me calculate it. You can use your calculators, please, to help me with this. So we have 70, so 70 divided by, how much? Divided by 65.4, 65.4, 65.4. Okay, for some reason it's not okay. All right, so that gives me 1.07 moles of zinc. Okay, fine. What is telling us this? It is telling me that in the reaction, it has actually 1.07 moles of zinc for making this reaction. Now, let's check for copper sulfate. So, I have 180 grams of copper sulfate, right? Again, so what relates grams with mole? Molar mass in the case of molecules. So copper sulfate has a molar mass of 159.61, let's say just 0.6 grams of copper sulfate, and that's the equivalent of 1 mole of copper sulfate. All right? Okay, so we can cross out, let me cross out this one as well. We can cross out grams with grams of copper sulfate, and I have now moles of copper sulfate. So how much is 180 divided by 159.6? I don't know how much is that. So let me calculate it. Let's calculate. So we have 180 grams divided by 159, 59.6, and the answer would be 1.12. No, 13. It would be the approximation because it's 1.127. Remember, we have to round up the second digit to reduce the amount of 6 figures to the same. So we have 3 6 figures, so I'm going to work with 3 6 figures as well. So that will be moles of copper sulfate. All right. What means this? So to know what is actually the translation of this answer is we have to pay attention to the ratios in the equation. So if I have 1 mole of zinc, I will have 1 mole of copper. How do I know that? Because of the stoichiometric coefficients. Remember, if there is no number close by to an element of molecule, it's because the number, it is 1. It is imaginary, it is not there. It's by convention we said, I don't want ones there. Okay, so but it is 1 mole and 1 mole. So what is the relationship between zinc and copper? The relationship between zinc and copper, let's write it right here. So zinc-copper relationship, it is 1 to 1. It is required 1 mole of zinc to produce 1 mole of copper. Let's do the same for copper sulfate. So copper sulfate with copper. every mole of copper sulfate is going to turn into a mole of copper. So it is also 1 to 1. If the amount of moles of copper or the amount of moles of copper sulfate are the equivalent of the amount by each of them to the moles of copper, so how many moles of copper can produce 1 mole of zinc? So we use stoichiometry. We already know, following the ratio, that every single mole of zinc produces 1 mole of copper. Therefore, the amount of moles of copper produced is 1.07 moles of copper. If I apply the same with copper sulfate, I don't know if this is out of the frame or not. I think it's out of the frame. Give me a second. Is it out of the frame? Well, a tiny bit. Okay, so let's try to solve it as quickly as possible. So for copper sulfate, it's the same. It's 1 to 1. So 1 mole of copper sulfate, it produces 1 mole of copper. Therefore, this is going to produce me 1.13 moles of copper at the end. So which one will produce me the lower amount of product? Easily can be seen that it is the zinc. The one is going to produce us less amount of copper sulfate. So it means that the 70 grams, where I should write right here. So 70 grams of copper will be consumed to produce 1.0 mole of copper. So what would be then the value in terms of mass? Well, I know that 1 mole of copper, it is 63.5, if I'm not wrong. Is it 63.5? Yes, it is 63.5. 63.5 grams. So 1.07 times 63.5 will give me 67.9 grams of copper. Okay? So all my grams of, I'm sorry, I just made a terrible mistake. It is 70 grams of zinc. My apologies. 70 grams of zinc will produce 67.9 grams of copper. And we will have, and we can just leave it there with the amount of copper produced. But if you want to, we can go forward and also find how is the amount of excess reagent that we have. So we have 1.71, we have the moles of copper sulfate. Okay, so let's do it. So the relationship is 1 to 1, so I have 1.17, so 1.13, but I'm going to consume only 1.07. The relationship between zinc and copper is 1 to 1. It is required 1 mole of zinc and 1 mole of copper sulfate to produce 1 mole of copper. So I can just do this. I can say that, let's use a different color. I can say that if I have 1.13 moles of copper sulfate, right? And this is 1 to 1, so I'm going to use 1.07 of moles of zinc. So I will consume let's not use moles to make it more simple. So because it's 1 to 1. So 1.013 moles of copper sulfate less the amount of zinc, which would be 1.07 moles. It means then I will have 0.06, yeah, 0.6 moles of copper sulfate that I'm not going to use. How I get this value? I got this value because this is my amount of copper sulfate. My total amount, 180 grams of copper sulfate, I just turn it into moles of copper sulfate. But, like the reaction is 1-to-1 copper sulfate, zinc, it means of 1.13 moles of copper sulfate is going to react with 1.07 moles of zinc, which means that they are going to consume all the moles of zinc, and I will have an excedent of copper sulfate would be 0.06 moles of copper sulfate. And if we translate that value into grams, it would be then 0.06 moles of copper sulfate, and I know that 1 mole of copper sulfate, it is 159 it is above because it's moles of copper sulfate, and I have 159.61 grams. My value would be, let's find it out. So it would be 159.61 times my value, which in this case is 0.06, and my result would be 9.57 grams of copper sulfate. It means that of 180 grams of copper sulfate, I will have at the end only 9.57 grams of copper sulfate and without react. And that's basically it. So this will be the excess reagent. The limiting reactant would be, in this case, zinc, and the lower amount of copper that I produce, it will be 67.9 grams. And that's it. Yeah, thank you very much, and that's it.